周哈，这样就会让我会让大家都比较难怎么讲？不能慢慢的教课了，辛苦一下。那理论上来讲，就是下礼拜，不对，下礼拜二考试，期末考。那下礼拜二我就会把课堂上完，礼拜三我们就不用上课，好，那让大家复习其他的考试。So just want to mention that I suppose finish this course next Tuesday. Okay, so next Wednesday we won't have course, and next Tuesday will be our final exam. All right, so let's continue our lecture. So yesterday we talked about how to draw molar circle. Okay, the molar circle is really elegant way to determine the stress status in all the direction, all the orientations. Okay, all you need to do is knowing sigma x, sigma y, tau xy, which is the norm, right? You know the value given by the problems, and then you draw sigma x1 right as the positive and downward positive for tau x1 y1. So this is really difficult, something different from our concept, okay? Different from our common sense, all right? And then we need to set up the center by set up sigma epsilon, sigma average, sigma x, sigma y average. Okay, so you can set the center of the molar circle, and then your R is this. And I believe you understand why this, because you remember that we built up the triangle, vertical triangle for solving the tangent P or tangent theta S, right? So you know this, and then you can find a circle here. But the most importantly, you need to set up the theta equal to 0 point. Okay, so this point is theta equal to 0. Your starting point, your first main focused plan, this one. So you need to define where is your original x. Okay, so you get your x by using sigma x tau xy, and then you get the point at the circle, and then the rest of the plan or any other orientation plan, you can just using rotate, but in rotate with the same direction, counterclockwise, and then your theta will be double in the molar circle space. Okay, you see here, green and blue, their difference, their theta difference is 90 degrees, but in the molar circle it becomes 180 degrees. So this is the two important things we need to memorize or address, pay attention to. Is in the molar circle, your tau x1 y1 is downward positive, and your circle, your theta in the molar circle will be doubled compared to the real world. All right, so this two concepts, which is not really directly connecting to our common sense, but these two concepts you need to understand. So after you set up plan A and plan B, and then rest of the plan like D plan, you can just start from the point A and then getting double theta D, and then you can get your D point in the molar circle, and then you can get sigma x1 and tau x1 y1. Okay, and all the points in this circle represent the stress status for different orientations. And you can see the circles with the most right points and most left point which is principal stresses, okay? And the highest stress, highest point and lowest point of this circle will be your maximum shear stresses. And then this is the example I stopped yesterday, okay? So we do the downward positive tau x1 y1 axis. We dump the sigma x1 positive to right axis, and this is the problem itself. It tells us, okay, sigma x equal to positive 90 megapascal, and this is sigma y positive 20 megapascal, and so sigma average will be 55 and R is 35. So here is 55 and this is 35, and of course your A here is 90 megapascal. So put here, and there's no tau here, right? No tau x1 y1, so nothing here. So you can set up, this is A theta theta equal to 0. All right, so it asks us to determine the stress status at the theta equal to 30. Okay, so theta equal to 30 degree. So sigma x1 equal to, right, so where is 30? You rotate x to 30, right? So in the space, you need to rotate 60, right? 60, okay? So in this direction, we call it point D, all right? And this is theta equal to 30 degree, all right? And I will write down, so what is the height? What is the height? 30 degree. So which means that we can just using graphic geometry condition, sigma average here, right? And adding one more stuff here, the length of here. So it should be R times cosine 60, right? So just not elementary, maybe junior high school level, 55 plus 35 cosine 60 degree, and you can get, it will be 72.5 megapascal. Okay, so you get that. And tau x1 y1 is also easy. What is the height of it? Okay, R sine 60. But don't forget that it is above the x-axis. So usually you should adding minus sign here. Okay, so minus 35 sine 60 degree equal to minus 30.3 m/. Okay, so now you know that the height here is 30.3 m/. All right, and I will, yeah. So that's it. Okay, and it asked us to draw the stress element, right? So this is 30 degree. It is 30 degree. Yeah, this is 30 degree. So suppose it should be, looks like this. Okay. All right, so this is, oh, perfect. So you can see 30 degree, 72.5. 72.5. Okay. This is 72.5 MPa. And of course, the opposite side, you will have 72. Ooh. Interesting. 72.5 MPa. Okay, so x1 direction, we have done that. So I will say this is x1 direction. Okay, and I would like to draw this is plan. We call this plan D, all right? Plan D. And this is the point D. Okay, so they represent together. Okay. Next, we have tau x1, y1, which is negative. So in this main focus plan, it will go down. Okay, go down. It should be 30.3 MPa. Okay, and then because the shear stress come in pair, so it will be 30.3 MPa. And because it come in pair, so yes. Okay, are we done? No, because we still have something here, the normal stress here. We haven't found it yet. So we need to find 90 degree. So we need to find the plan like this. Okay, the yellow plan. The yellow plan, we still need to find the normal. Where is the yellow plan? In the small circle. 90 degree in the real world become 180 degree in the small circle world. So you see 90 degree. Yeah. Okay. So 90 degree. So I will call it plan E. All right. Plan E. And of course, this is 60 degree. All right. So how can we, well, I should write down, make it a triangle here. And I use the triangle here to help us to determine the stress status. So it should be theta equal to 120, right? So the sigma x1 equal to 55 minus 35 cosine 60 degree, right? 37.5 megapascal. So you have the positive tensile in the plan E, 37.5 MPa, and then 37.5 MPa. Okay, simply as that. Very simple. Okay, so you can see that everything just junior high school standards. Okay, you know, once you get the concept, and you will know that. Very good. And the next page, you will experience very similar procedure, but I only have 3 minutes. So I will just give you some I'll just give you some beginning, starting point for you for the next page. All right. And I encourage you go back home and you do the rest of the procedure. Easy. Okay. Don't worry about that. You will later you will find that the point may shift around along the axis. All right, later. 2 minutes. So later I will give you the problems or the problem. Okay, so next page, go. So we have okay, compressive. Okay, this is a little bit different. Okay. So this is 50 MPa, and this is 40 MPa, and this is 10 MPa. Okay, so you can immediately get that sigma average will equal to minus 50 plus 10 divided by 2. So don't forget 50 now is negative because this is compression. Your R is minus 50 minus 2, 10 divided by 2 square plus 40 square. So you will have 50 MPa. Okay, so now we know where is the center, tau x1, y1. This is sigma x1. And we know that is always here, minus 20. Okay, 20. Okay, and 50 as the R. All right, so hey, tweak a bit. All right. Hey, I hope you understand this, but yeah. So here, of course, this is 50. All right. So I would like you to continue this because I starting a figure here, and I would like you to point out where is the point A here? Where is point A? And then you can derive the 45 degree after you pinpoint the point of A. All right, so yeah, today that's all for today. Thank you for coming, and you will have a rest. Thank you very much. If you have any questions, just come here. Thank you. 接下来我只剩下20页，20页的话，我马上就可以教完啦。下个礼拜二应该1节半吧，我猜。OK。